Welcome back to the Cybercrime Lab. You ever wonder how computers save and delete information off of a hard drive? Well, first, there's two types of hard drives. First, there's the standard hard drive, which is considered an electromagnetic hard drive, and it consists of multiple layers of platters that save information. Now, these platters are spinning at a rate of between 5,400 revolutions per minute up to 10,000 revolutions per minute. We also have solid-state hard drives, but solid-state hard drives save information in a slightly different way, so we're going to talk about those in another video. Now, these platters that we were talking about conceptually look like this. They're separated into concentric circles called tracks, and these tracks are where information is stored. You've heard everything is binary. Well, that's what it means. Everything is either a positively or negatively charged ion, which is either a 1 or a 0. And if you take those ones and zeros and you put them together, in this example, you get an A, B, C, or D, and that's considered ASCII. And that's how information is stored on a computer. It's all positively or negatively charged ions. It's all binary, and that information is read by the computer in large chunks, and it is either letters, files, or applications that run on the computer. Now, these tracks are also subdivided into sectors. And the sectors are what actually hold individual addresses where files are stored. A hard drive is very similar to a book, a very large book, and every book has a table of contents. So when you save a file and you want to go to chapter 13, all you do is you look in the table of contents and it says chapter 13 starts on page 300. Very, very similar to the way hard drives save information. If I were to create a file, and let's say this file was my list of drugs, it's a Word document, and this file was 8 pages long. Well, while I'm typing that file, before I hit save, where is that information? It's stored in RAM, and we'll talk about that in another video. But that information, once I click the Save button, your operating system goes to the hard drive's table of contents and says, I have an 8-page document, where can I save this information? The table of contents says, page 68 through 75 are free, you can save it there, and it's annotated in the table of contents. Now, when I delete a file on a computer, all that's really happening is it changes the first character of the file name in the table of contents. That's right, the file itself is not deleted. It remains on that computer. So if someone asked you, how long is a file on a computer, or how long is a deleted file on a computer? That file remains there forever until it's overwritten. So if a judge ever asks you, this file was on his computer years ago, what's the likelihood that it would still be there? You can say that files saved on a hard drive are there even if they're deleted forever until they're overwritten. So let's say I save a picture of a grenade, and I go to the table of contents and it says, your grenade is 8 pages long, where can I save that? The table of contents says you can start saving that at page 72. Well, you can now see that on page 72 through 79, I have the picture of the grenade. But with our forensic tools, if I were to look on page 68 through 71, I would see the first 4 pages of the list of drugs. And I could recover those first 4 pages forever until they're overwritten. So if I delete the grenade picture, again, all that happens is in the table of contents, it changes the first character of the file name, but the file is still there. Now, if I save another file, and in this case, it's a picture of a revolver, and it's 12 pages. So when I save that picture of the revolver, the table of contents says, start on page 76, and it's 12 pages long, so you can go through page 87. So, with our forensic tools, if we were to look at page 68 through 71, I'd still be able to recover the first 4 pages of the list of drugs, and page 72 through 75 would be the first portions of the picture of the grenade. And again, deleting that picture of the revolver only changes the first character of the file name in the table of contents. But that file is there how long? Forever until it's overwritten. Now, or nearly every file has what they call file signatures. And these are kind of like road signs on the road where it says road work ahead and then road work ends here. Well, file signatures are the same. It tells you where the start of the file is and where the end of the file is. Some files, as an example, like a picture file, its file header is Yoya. That's what we look for in the forensics lab, is we look for Yoya and we know that's the beginning of a picture file. So with our forensic tools, what we do is we carve through, look through every page of that hard drive, and we look for those file headers, and we carve out those files that are on the computer, whether the table of contents says they're there or not. And in this case, you can see we get the first couple of pages of the list of drugs, part of the hand grenade picture, and the entire revolver picture. And then, again, by deleting the revolver, that file is there forever until it's overwritten. So if I were to save a movie file called explosion.mov, and the table of contents says you can save this file starting on page 68 through 91 because it's 24 pages large, then we can never recover the list of drugs, the grenade picture, or the revolver picture because they've been overwritten. But wait, even though we can't recover the files themselves, there are many forensic artifacts on a hard drive in an operating system that tell us that those files were there and whether they were opened and what happened to them. This is an example of a link file that shows that that list of drugs was saved on this person's desktop, and we can even tell when that file was last opened. And then there are other locations throughout the computer. This is a registry key, again showing the list of drugs document was once there and that it was open. So just because we can't recover the file, or just because that file was never on the computer, remember, the computer is remembering in other locations, other forensic artifacts, everything that you do, all the files that you're opening, and we may be able to find evidence that that file was once either on the computer and can't be recovered or was opened from an external storage device. Now, in this last example, I showed you the ideal way that files are saved, and that's in contiguous format, which means one page right after another. But in actuality, that's not how computers really save information. You've all probably heard of your hard drive being fragmented. Well, that's because files get scattered across that hard drive platter, and it's not as easy as just looking at one page after another. As a matter of fact, it's kind of like looking at a stack of shredded paper. And because hard drives can save so much information, that stack of paper is more like pallets and pallets of shredded paper. I'm trying to get a little sympathy for the digital investigative analysts out there that have to go through all this shredded paper. So that's how hard drives save and delete files. Hope you enjoyed this. Check out some more of our videos to find out new information about other technologies.